This class already been started?
Yeah. So, okay, so I will start with normed linear space today. So before that, I will just discuss some linear algebra, some basic linear algebra. You all might have know that, but I just should recall it. Obirupta, please mute yourself. Okay, I think you guys can see my screen now. Okay, so what is vector space?
Madam, I am not. I can see your screen.
Yeah, what? তুমি বাংলায় বলতে পারো সৌরভ, কোনো অসুবিধা নেই।
ম্যাডাম স্ক্রিন তো দেখা যাচ্ছে না, মানে পুরোটাই তো একদম ডার্ক আসছে।
হ্যাঁ হ্যাঁ, দেখো এবার লিখছি, দেখা যাচ্ছে?
না না না, না তো
দেখা যাচ্ছে না? আচ্ছা, এনি
Hold
আদার?
up, you can just disconnect and then reconnect. I think that's down to your network because I mean her screen is perfectly visible.
সৌরভ, তুমি একবার ডিসকানেক্টেড হয়ে আরেকবার জয়েন করো, হয়তো তোমার কোনো নেটওয়ার্কের সমস্যা হচ্ছে। আচ্ছা, so what is vector space? So a vector space over a field is a set V whose elements are called vectors, as we know, and on which there are two operations, addition and multiplication, which are defined. And so addition, I'm not writing the full definition as you all know this, so I'm not writing it. Yes. So this is the addition, and this addition, the property of addition, I mean this operation of addition will follow some properties. First is commutativity. Commutativity, I think you all know. Commutativity means x plus y is equal to y plus x. Second property is associativity. Associativity is this. This property is called associativity. Okay. And the third one is there exists an unique vector, which is 0 basically, which is called actually the 0 vector, such that for all x, I think you are familiar to these notations. There exists, it's called for all. Okay. So for all x belonging to V, x plus 0 is equal to x. And the fourth one is, as you might guess it, it's an inverse. So for every x belonging to V, there exists an unique vector minus x belonging to V, such that x plus minus x is 0. So for a vector space, addition will follow these four properties. Okay. And number 5 is basically multiplication. So let me define multiplication first. Multiplication, scalar multiplication is better than multiplication. I mean, scalar multiplication is more precise than multiplication. So it's basically this. Okay, so we can define it like this. So basically it's if cross P to V such that alpha comma x goes to alpha x. Okay. So scalar multiplication will also follow some properties. For every x belonging to V, 1 dot x is equal to x, where 1 is the multiplication identity. . for all A comma B belonging to F, and for all X belonging to V, alpha into beta X is equal to this. Seventh property is distribution over addition for all alpha comma B belonging to F, and for all X belonging to V, alpha plus B into X equal to alpha X plus beta X, and the last for all alpha belonging to F and for all X comma Y belonging to V, alpha into X plus Y is equal to alpha X plus alpha Y. So as you all know, this is called vector space, and I have written down all the properties of vector space. This is the structure of vector space basically. So what is called finite dimensional vector space? What is basis? What is basis? So linearly independent and the spanning set, right? So a linear independent and spanning set of the vector space is called basis. And what is linearly independent? Linearly independent means if x1, x2, these are linearly independent, then c1 x1 plus c2 x2 dot 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 is equal to 0, then c1, c2 will also be 0. Okay, all linearly dependent means at least one of them will be non-zero, at least one of the constants or one of the coefficients is non-zero. That is what linearly dependent and independent means. Now what is finite dimensional? I am going fast because you all know this basic linear algebra. Otherwise you should not do functional analysis. So what is called finite dimensional vector space? A vector space whose basis has finite elements is called finite dimensional vector space, and a vector space whose basis has infinite elements, that is called infinite dimensional vector space. So what is the standard basis of Rn? Anyone? What is the standard basis of Rn? I'm asking
E1
you.
into dot dot dot
What? What?
E1 into dot 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 En, where EI is EI is the core n tuple, where at the ith entry is 1 and
Yes.
rest is
Good. Yes. This is what he is trying to say. So this is the standard basis of Rn. Okay, so what is called linear functional? Sort of. What is called linear functional?
if V is a vector space over a field F, then any linear map from V to
V
F,
to F.
where F is seen as a vector space over F itself, is called a linear.
Exactly. So any linear map from V to F is called linear functional, or what is called linear transformation. What is called linear transformation?
Any map from a
linear transformation. So you should say any linear map, right? Any linear map from V to W is called linear
if
transformation.
it preserves the two operation, the scalar computation and addition.
This one, right? This one. See? This one, right? So this is linearity. X plus y is equal to tx plus ty, and t of alpha x is equal to alpha tx. So we can just sum up this and we can write this. T of alpha x plus beta y is equal to alpha tx plus beta ty. Okay, so that is what linear transformation is. Okay, so what is called rank and kernel?
Dimension of range space is defined to be rank
Yes,
of the underlying linear map, and kernel is the dimension of null space.
Dimension of null
kernel
space.
is the null space itself.
Yes, so this is what kernel is, right? Or nullity is the dimension of the kernel space, right? Or null space. dimension of kernel. Okay, so yes. Now I want to know, do you all know what is eigenvalue, eigenvector, algebraic multiplicity, geometric multiplicity, everything? You should know that.
Madam, to how much extent it is regard, or actually I know up to just that the definition and some just result, but not minimal polynomial and the other blah, blah.
Okay, so as of now, we won't need it, but we need it later. Okay, so I will teach. If you will be there, then you will understand. Okay, so now coming to norm, the showstopper of this class. Norm. What is norm? Basically, norm is a function. A norm on a vector space V is a function from,
Excuse me, madam. V has to be over R or C, I think. Otherwise, it
yes,
can.
V is, of course. And as of now, as far as we teach functional analysis, my field will be either R or C. Okay. So field is R or C. Such that, firstly, norm x is equal to 0 if and only if x equal to 0, for all alpha belonging to F and x belonging to V. And the third one is triangle inequality, as you all know, for all x comma y belonging to V. So that is what norm is. And what is now? So can we guess what is normed linear space? What is normed linear space? This is what is norm is. Okay. What is normed linear space?
Uh, when the underlying vector space is over R or C and there is a norm defined on it.
Yes.
In the pair, I mean,
Yes. A normed linear space is a vector space, basically induced with the norm. Right. So a non-linear space is a vector space. I'm writing it Vs, endowed or induced, whatever you want to say. It's called non-linear space. Okay, good. Now coming to Banach space. So my functional analysis will start from this. As far as we have taught non-linear space, you guys must know this in your linear algebra course. Now I will teach what is functional analysis. Functional analysis deals with such spaces, Banach space, Hilbert space. So there are so many space that you will see right now. Now this is the first basic thing, that Banach space. What is Banach space? Banach space means, okay, so have you done your topology course? Do you know completeness? What is complete? What is completeness? Completeness का मतलब क्या होता है?
every Cauchy sequence converges in that space.
Every Cauchy sequences will convergent, right? Okay, so other than sort of, I am asking Anjali, Karan, do you know guys what is completeness? If you can't talk, then you can just write it down in your chat box. Okay, very good. Anjali, पता है completeness? Okay, very good, very good. Okay, so Banach space is a non-linear space is said to be Banach if it is complete under norm. If it is complete under that norm. What is the meaning of this? So the meaning is, if you get a Cauchy sequence in that norm space, it will be convergent with the norm. Okay. So I will show you how to prove a Banach space, how to show that this is a Banach space. Let me show you first. Okay. So do you guys know R is complete? R is a complete space. Do you guys know? You should learn this in your first year or second year of your BSc. Yes, ma'am. Okay. अंजलि पता है? Okay, good. Okay, so if R is complete, then we can just write it down. One of the big example is Rn. Okay, so let's take Rn and we can define a norm there. What is the norm here? The norm will be, as we know, the elements, like what is the elements of Rn? What is the element? How does the element should look like? X1 n tuple vectors, very good. In x1, x2, x3, xn. Yes, this is the element of Rn. Very good. So define I equal to 1 to n xi to the power p to the power 1 by p. So this we can just we have now just defined the norm, and now we will show that this is a norm. It's very easy, very easy. See, first is you have to show that if this is equals to 0, then x equals to 0. Obviously, because all the things are positive there, because this is modulus of xi, right? And modulus of, and the summation of positive things is 0. It means that all of the things are 0. I mean, xi to the power p I equal to 1 to n is 0. That means x1 is 0, x2 is 0, xn is 0. So x1 is 0, x2 is 0, and xn is also 0. So that's how x equals to 0. Okay, very good. So what was our second property? Or if, its converse is also true. If x equals to 0, then obviously this is equals to 0. What is our second property? Second property was this. What should be the case? It's alpha to the power p and xi to the power p, and it's a constant, so we can just take this constant out of the bracket and we can just do this. Very good. Okay. Now we will just show the triangle inequality, which will be an exercise because this is a very, very childish thing to prove triangle inequality right now. Okay. So I will just show why is Rn a complete space with respect to this norm. Okay, so take a Cauchy sequence. Always, when you have to show that this is a complete space, you need to take a Cauchy sequence. At first, you need to take a Cauchy sequence. Okay, so take a Cauchy sequence. Xn in Rn. Very good. Okay, so if Xn in Rn, as Karan said just before, Xn means it's a n tuple vectors, right? So each of the tuple, I mean, if x1 n, x2 n, that's how xn n. If that is the sequence, then x1 n is Cauchy R. Similarly, x2n is also Cauchy R. So all the tuples are Cauchy in R, and we know that R is complete. So x1n will convergent. That's how x2n will convergent. So we have got that this sequence called xn is convergent to x. Convergent to x. Okay. Which is also a element of Rn. I mean x1n is convergent to x1, x2n is convergent to x2. That's how it is. Xn is convergent to xn. Okay, so my Rn is complete with the norm. So what have you used in this proof? So what is the upshot of this proof? What is the ingredient of the proof? Can you guys tell me what is the ingredient of the proof? What is the thing that you have used? Bolo?
completeness of R.
What?
R এর completeness-টা আমরা এখানে use করছি।
Tick, tick. So we have used the completeness of R mostly. Okay, so we will now do some inequalities which is called Onder-Holder inequality, Minkowski's inequality. We will do this, okay, first. So first, lemma. Let P is greater than 1, less than infinity, and 1 by P plus 1 by Q is 1. If A and B are non-negative real numbers, R plus union 0, A comma B belongs to R plus union 0. I mean A comma B are non-negative real numbers, then we have A to the power 1 by P, B to the power 1 by Q is less than A by P plus B by Q. Okay, so it's 10:47 right now. I'm giving you 3 minutes. Just try this proof using some increasing function, decreasing function. This is a hint that you should try this proof with an increasing function or a decreasing function. Okay, so just try it. Giving you 3 minutes. You guys have to try, okay? So I will not, it's not my way of teaching to spoon feed. I don't spoon feed. So if you have to learn under me, then you have to do it on your own. I will give you time, but you have to tell me, you have to talk with me, you have to converse with me. You have to do this. My classes are always used to be interactive. I never taught to not taught a class like this. Okay, so the time is over. What have you done? Anyone? Please. Shabid. Yes, please. Shabid. Have you done anything? Okay. So you should. Oh,
Ma'am,
yes, please.
arithmetic mean greater than or equal to geometric mean A and B with weights 1 by P and 1 by Q with 1 by P plus 1 by Q equal to 1.
Not
This
arithmetic. It's not arithmetic mean. What is called an arithmetic mean? What is the definition of arithmetic mean? If
A
given,
with
hmm,
A with weight 1 by P, B with weight 1 by Q, AM greater than or equal to GM subject to 1 by P plus 1 by Q equal to 1.
yeah. So what? What is your arithmetic mean here? From where have you got the arithmetic mean?
A into 1 by P plus B into 1 by Q all divided by 1 by P plus 1 by
Arithmetic.
Q.
What is the definition of arithmetic mean? What is the definition of arithmetic mean? If given A and B are two numbers, then what is the arithmetic mean of A and B? What should be the arithmetic mean of A and B? Arithmetic mean is this, and geometric mean is this. This result is true, but this is not this result. I have told that P and Q are from 1 to infinity. So it can be anything the number between 1 and infinity. Okay, so have you got your mistake? Have you understood?
Okay.
Okay. So take fx is equal to k into t minus 1 minus t for k plus 1, where t is greater than equal to 1. Okay. For some k belonging to 0, 1. Now just do this. F dash t. Just do this. F dash t. What will be the F dash t? Tell me. What is the F dash t? F t is this. What is F dash t?
K minus kt to the power k minus.
Yes. So if k is less than 1, t is greater than 1, then f dash t greater than equal to 0. So f is an increasing function between 1 to infinity. Now you can just check if 1 is equals to 0. See, if 1 is equals to 0, because this is 1, I mean, this is, of course, this is 0 and minus 1 plus 1, so f of 1 is 0. So if f of 1 is 0, we know that t to the power k is less than k into t minus 1 plus 1, for t is greater than equal to 1 and k is greater than 0, less than. Okay. Now just substitute. T is equal to A by B and K is equal to 1 by 2 in this inequality. In star. Okay, so that's just complete the proof and we will get the claim. Okay, so now coming to
Madam, is it known as Young's inequality?
absolutely not. Young's inequality is something else. It's not Young inequality. Holders. So do you know convolution?
But
So I am asking you, do you know convolution?
no, no.
No, so Young's inequality is based on that. Okay. So coming to
But I have seen in Kumar-san's books this.
okay, for now we don't require that. Okay. So Holder's inequality. Holder's inequality is let p is greater than 1, less than infinity. Then for and also 1 by p plus 1 by p q is equal to 1. Then for x comma y belonging to Rn, summation I equal to 1 to n xi yi is less than equal to this. This is a very useful inequality. This is a very useful inequality. We will use this probably in every time until you are doing maths. Okay, so until you are not doing maths. So yes, just prove it. You can just take a is equal to xi by p by this, and b is equal to yi to the power q by, okay, and put it in the above inequality. This one, put it, just do it, just do it. It's 10:59 right now, and I will ask you by 11:02. I have told you what will be your A and B. Just put it in star. It's very easy. Okay. I'm expecting at least one of you will do this. Just put A and B in star. I mean this star. Or we can make it a double star. Is there anyone who has done it? Anjali, have you done it? Why are you guys silent? I mean, hmm, no. Why? What is the problem? Just tell me the problem. Mm, Switch on your mic and talk to me. I mean, I am not a tiger. I'm a human being. You can talk to me. What is the problem? Haven't you understood or what?
Madam, now we can, I think, sum up over I or J from 1 to n.
Okay, so you will tell me. I will just do it. Okay. So my A is this and B is this, and my inequality was A by P by B by Q is greater than equal to A by 1 by P, B to the power 1 by Q. Very good. Now we can just do this. Okay. So what is the next step, Saurabh?
Now I think we can sum up from I runs from 1 to n. Means summing over I and then adding the we get the required quantity.
Okay. Anjali, have you understood right now? Have you got the point? You can just talk like, okay, very good. Now you can just finish the proof. I will not do it anymore. Okay. My next inequality is Minkowski's inequality. Let P is greater than 1, less than infinity, and let x comma y belonging to Rn, then x plus y, pth norm of x plus y is less than pth norm of x and pth norm of y. So please use your inequality.
Excuse me, madam, I have a question here. If P equal to 1, then what will be the value of Q? I
What is
mean,
the value of, have you have like in this inequality, is there any q or is there any
no,
r?
actually, for previous inequality, it was that.
So you should get me, right? You should get me. What will be Q? If P is 1, then 1 plus 1 by Q is equal to 1. So 1 by Q is what? What is the value of 1 by Q?
But there is no such real value of Q such that 1 with Q is 0.
It's infinity, right? If Q is infinity, then 1 by Q is 0. Okay? So if P is 1, then your Q will be infinity. Okay? Okay. So now do it. Minkowski's inequality. Use your holder and do it.
Madam, I think we can use triangle equal. I mean,
What is your first step?
uh, x plus. I mean, if we relate x equal to x1, x2 up to xn, and y equal to y1 up to
Wait,
yn.
wait. Ruko. X plus pth norm of x plus y. What is this? Pth norm of x plus y.
Uh, xi plus yi modulus to the power p, summation in from 1 to n to the power 1 by
You
n.
should say summation I equal to 1 to n xi plus mod of xi plus yi to the power p whole to the power 1 by p. Okay. This, right? Okay, very good. Now, if I just take this, just use holder. You tell me, sort of.
We can parts. I mean, we can separate one single term, such as p equal to 1 plus p minus 1, and then less equal to
What? What?
mod
What? 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 Xi plus yi to the power. What should I
p
write?
minus 1
Hmm.
into mod xi and plus yes.
Okay. Now what? What is the next?
And then just using the distributive property, and then we apply Holder's inequality in each summand.
Can you just repeat?
I want to say that now just mod x, I mean mod x now, if we apply Holder's inequality in each summand of the terms
Yes, you should
mod
apply.
x,
Hmm.
and then it will be such as the first term is equal to mod x, sorry, norm p.
Mod P.
No, the norm p.
You're talking about this.
Yes.
Then
Norm p into summation. Uh,
come on, it's a very easy thing. Please, guys, complete this proof. Please.
and summation I run from 1 to n.
Mod xp, fine. Summation I equal to 1 to n. Then what?
Mod xi plus yi to the power p minus 1 whole to the power q. I mean,
P minus
and
1 whole to the power q. What is this? Whole to the power q.
मतलब जो समेशन का अंदर जो टर्म है उसका होल टू दी पावर की. Actually, I am using the result that xi plus yi whole to the power p minus 1 uska whole mod equal to mod ka power p minus 1. That's the basic. I am using this. And then applying holders.
Okay, so you guys just complete this proof and send it. Okay, just complete this proof and send it. It's a very easy proof. I will not do like this is the holder inequality we have got. This is the holder inequality, and now if you can't use this holder inequality to get something very easy, then but is the next. Okay, so moving on to the next thing. In RL, we can define another norm. Why is it a norm? Is there anyone who is listening to me except Saurabh? Saurabh is there, but is there anyone who is listening to me? Why is it a norm? Okay, so what is the properties of norm? Norm of x is 0. That implies maximum I equal to 1 to n xi is 0. So as this is a positive term, so mod of xi is 0. So yes, xi is 0 for all I. So converse is also true. If x equals to 0, then L infinity of x is also 0. And if it's alpha x, then of course mod alpha will be out, and yes. And the third property is the triangle inequality, which is the most easy thing here, because if it's L infinity norm of x plus y, then its maximum of I equal to 1 to n xi plus yi. Now it's just use the triangle inequality for this, I mean for r, because we know we can use the triangle inequality for r. So yes, so that is why it's a norm. And now again you have to verify that it's a complete space with this. I mean Rn is a, we can define multiple norm on a vector space. Rn is a non-linear space with respect to LP norm, and Rn is also a non-linear space with this sup norm. We call it sup norm. Okay, so it's also, I mean, uh, complete with respect to this norm. So can anyone tell me why it's a, why is it complete? Because I have just told you guys that just take a Cauchy sequence and make it converge with respect to that norm. Can you guys tell me?
If we take any Cauchy sequence xn in the space, suppose uh, then the corresponding coordinate sequence is Cauchy in R, and which is uh, complete by
What?
applying the triangle.
What? What? Repeat once again. Repeat once again. I couldn't repeat. Sure of it.
Yeah, if we take any Cauchy sequence xn in that space, infinity, then
Yes.
then the coordinate sequence, I mean the sequence consisting of the first entry of that terms of the sequence, and the sequence consisting of the second uh, entries of the sequences, and in this way all such sequences is
Have you
Cauchy.
noticed something that maximum of xi means if there is a sequence like x, as I have told. Oh, তুমি তো একাই আছো এখন. Okay. So if xn is a sequence, then x1 and x2 and এর মধ্যে থেকে যে জিনিসটা তুমি বলছো সেটা একটা সিঙ্গেল নাম্বার, সেটা একটা সিঙ্গেল টাপল। তো যদি একটা সিঙ্গেল টাপল তুমি নাও, সেই সিঙ্গেল টাপলটা আর এ চলে যায় এবং আর ইজ কমপ্লিট। সো ইয়েস, দিস ইজ কমপ্লিট, because if you take a Cauchy sequence in Rn with respect to L infinity norm, then what is the meaning of this? The, সেটার অর্থ হচ্ছে বেসিক্যালি একটা xin is Cauchy in R, and that means that Cauchy is convergent because R is complete. So yes, you are done. It's the most easiest thing. Okay, so
Please repeat.
তুমি বাংলায় বলো, কেউ নেই আর।
হ্যাঁ, মানে কোচিনেসের যে ডেফিনিশনটা ইউজ করলেই তো আসছে যে ম্যাক্সিমাম অফ সাপোজ।
ওয়েট, আমার কথা শোনো। তোমাকে 1 2 3 4 5 দেওয়া হলো, ম্যাক্সিমাম তুলতে বলা হয়েছে, তুমি তো 5ই তুলবে, বাকিগুলো তো তুলবে না। জাস্ট এখানে সেটাই করা হচ্ছে। যদি x1n x2n এখান থেকে একটা ম্যাক্সিমাম তুলতে বলা হয়, তাহলে তো সেটা xin বা এরকম কিছু একটা, ফর সাম i ইটস xin, রাইট? xin কার এলিমেন্ট? আর এর এলিমেন্ট, রাইট? ইয়েস অর নো? আর এর এলিমেন্ট, হ্যাঁ কি না?
তখন ডিস্ট্রাক্ট হয়ে যাচ্ছে, মানে এটা সেম নাও থাকতে।
মানে আমি বুঝতে পারছি না কি বলছো তুমি।
আচ্ছা আচ্ছা, তাহলে ওটা কিরকম ভাবে?
তুমি একটা টাপেলকে তুলছো, ম্যাক্সিমাম তুলছো মানে তুমি একটা টাপেলকে তুলছো। একটা টাপেল তো সবসময় আরই রয়েছে, প্রত্যেকটা টাপেল আরে রয়েছে বলেই তো ইটস এলিমেন্ট অফ আর এন, রাইট?
এবার যদি ম্যাক্সিমামটা যদি আহ, আহ, এর মধ্যে থাকে, মানে ম্যাক্সিমামের ডিস্টেন্সটা যখন, মানে সেটা তো
ডিস্টেন্স
ফর সাম জে, মানে ফর সাম জে কোঅর্ডিনেট তো ওটা লেস দ্যান এপসাইলন হলো, তাহলে আমার সবগুলি জন্যই তো লেস দ্যান এপসাইলন হয়ে যাচ্ছে না?
কি বলছো লেস দ্যান গ্রেটার দ্যান? 1 থেকে 1 থেকে 5 নাও, ম্যাক্সিমাম তো একটাই এলিমেন্ট হয় 1 থেকে 5 এর মধ্যে। তাই নয় কি? 1 থেকে 5 এর মধ্যে ম্যাক্সিমাম যদি নিতে বলো তাহলে তো 5ই হবে, 4 হবে
হ্যাঁ
কি?
হ্যাঁ, সেটা তো হলোই, কিন্তু তারপরে আমি মানে এমন তো আমাকে কোনো আরএন এর মধ্যে কোনো পয়েন্ট খুঁজে পেতে হবে যেটাতে ওই মানে ইন ট্রাপেলের সিকোয়েন্সটা কনভার্স করে, সেইটার আমি আর কি খুঁজছিলাম। ওটা তো আমাকে ওই মানে ওটা তো একটা সিকোয়েন্স অফ সেইং আর,
তুমি
যেটা
এটা
আর
বুঝেছো
এর
যে আমি একটা কথা বলেছিলাম যে কষে সিকোয়েন্সটাকে কনভার্জেন্ট হতে হবে উইথ রেসপেক্ট টু দ্যাট নর্ম। তার মানে কি বুঝেছো? তার মানে হচ্ছে যে এইটা, if xn is a sequence then this should go to 0. ওকে, আমি তোমায় বলিনি xn টা x এ কনভার্জ করবে, এটা বলিনি। আমি বলেছি উইথ রেসপেক্ট টু দিস নর্ম xn converges to x, না হলে what is the meaning of norm, what is the point of introducing norm? যদি আমি এমনি এমনি বলতাম একটা কত সিকোয়েন্স কনভার্জ করেছে, আইডিয়াটা বুঝেছো? নর্মের রেসপেক্টে কনভার্জ করতে হবে, তার মানে কি ম্যাক্সিমাম অফ xin minus maximum of, I mean maximum of xin converges to some x which we don't know right now, but my x is, because r is complete, so my x is the limit of xin, because xin is Gaussian r, so xin converges to some element. এবার বুঝেছো?
আচ্ছা, হ্যাঁ,
বুঝেছো কি, মানে নাকি আমি আবার রিপিট করব? আচ্ছা,
হ্যাঁ, মানে আসলে আমি ধরুন মানে ওটা তো ম্যাক্সিমামটা আমাকে দেখাতে হবে আর কি, জিরো হয়ে যাচ্ছে।
কাজ করো, বাড়িতে একটু বিষয়টা ভাবো, বুঝতে পারবে। 1 থেকে 5 এর যে এক্সাম্পলটা দিলাম ওটা দিয়ে ভাবো, বুঝতে পারবে। ঠিক আছে, চলো আজকের মতন শেষ করছি আমি।
উম,